All right, welcome everybody to Cloud Native Madison's March Meetup 2020. This is the 1 year anniversary from when we started Cloud Native Madison. So 10 events since then. This is the 11th, and so I want to thank everybody who's participated in any way, whether this is your first time or 11th time. We've definitely, had a great experience running this. We've learned a lot. For example, I can tell you without doubt these lights are going to go off at 7 p.m. tonight. Also, having these meetups next to a busy kitchen is not fun. But yeah, we've had a lot of fun running this, and love to see how many people we can get out every month. We did send out a new member survey for the 2020 year just today. So if you are a member on the Meetup site, you should have that in your email. Please do take just a couple of minutes to fill that out so we can make sure that we're aware of the topics, content, and just logistical stuff like location that we can make sure we're best serving our community for. I've got just a couple of quick slides. I want to thank TeamSoft again for sponsoring us in February. If you didn't get a chance to attend that, or you want to check out some of the other meetups we've had, we do have our own YouTube channel. You just search Cloud Native Madison. We've got most of our talks there, all the talks where we didn't run into some unforeseen AV issues. So check us out there. We are having another meetup here next month. It's sponsored by Logs.io. Logs.io is a partner of us here at Integral. For those of you who may not be aware, they're essentially an Elasticsearch Log-Kibana as a service offering. They're not coming to do a vendor talk, though. They're bringing one of their customer success engineers, Ashley Somerville, to give a talk on building your own open source observability stack for Kubernetes. So we're very happy to be hosting them here next month. I wanted to briefly talk about the yearly CNCF, Cloud Native Computing Foundation survey that just came out this last month. Usually at the beginning of these talks, we kind of review what's been happening in the cloud native space, but there's some really interesting stuff in here in terms of how the community is evolving, how companies are starting to adopt all the different projects that are associated with CNCF. So I thought I'd talk about that a little bit. And as a little bit of pretext, I wanted to point this out. Most people have probably seen something like this. This is called the innovation adoption cycle, or sometimes the dispersion of innovation, if you will. And what it's trying to capture is sort of like market share in terms of how companies adopt software. And certainly fair to say that most of the software in the cloud native community space is really new. And we've seen, starting with that kernel of Kubernetes being donated to the CNCF just 4 or 5 years ago, just an explosion of experimentation in this space, starting with Kubernetes as that common substrate. So I just wanted to throw this up here as we review some of the survey results in context here. So the first thing they released here was just use of containers that they've been surveying on since March of 2016. And so probably not a surprise that most companies started adopting Docker and containerized technologies in their development environments, right? I'm sure a bunch of people out there who've been developing for a while remember standing up these massive Vagrant setups in order to launch a bunch of VMs to run your workloads. And when Docker came on the scene, that kind of stuff went away pretty quickly. And it was obviously early on a pretty compelling tool for local development. But then as the years progressed and the industry started to figure out, okay, how can we run these things in production? What are the benefits we get from that? What are the problems we have to solve to get there? We've actually seen, I think, a staggering increase in adoption. So if you think just 4 years ago, 23% of companies running containers in production, now 84% of survey respondents are actually running containers in production. I think it just goes to show how compelling this suite of technologies are and how quickly they are being adopted. These are the CNCF graduated projects. So for those of you that aren't aware, CNCF has their own kind of project maturity model, starting with sandbox, moving on to incubation, and then finally going on to graduated. And at each one of those, there's a gate of code review, security review, what is the adoption, is this a project that will live on if the creators step back from it? And so these are all the ones that are considered graduated. And you'll notice in 2019, a large percentage of the survey respondents are actually running Kubernetes in production. And so that's, when we first started this a year ago, a couple of us would talk about, what's really intriguing about this community is that if things go the way they should, Kubernetes has kind of become the most boring aspect of all this. It's really about all the other interesting stuff you can do on top of Kubernetes that Kubernetes enables. And so I think we've very quickly seen, heavy adoption of Kubernetes, and now we're starting to say, okay, we've got that. What else can we start to do? We see large adoption rates with Prometheus as well, Envoy. Some of these other projects, though, that are graduated are still lagging, and I think we'll continue to see that trend up in the future. But I think two of the most interesting spaces that are evolving now on top of Kubernetes are service mesh and then serverless technologies. And so I wanted to highlight the results around the service mesh here. And so only 18% of survey respondents for the CNCF are actually using some sort of service mesh in production. And for us here at Integral, service mesh was one of the more compelling reasons to even get to Kubernetes in the first place. And for those of you that may not be aware, the idea of service mesh is that you kind of have this smart kind of software-defined networking layer connecting all of your applications together to do things like retrying bad requests, circuit breaking on load, giving you additional observability like distributed tracing, kind of all automatically because it's sort of sitting on the wire. And so you no longer have to build those things right into your application. You can deploy it out as a service and then just wire your apps into it. And it's very, very flexible that way. So like I said, only 18% of respondents are actually doing this in production, but over half are interested in doing it in production. So as we've seen Kubernetes become, the de facto way to, deploy kind of greenfield container-based applications, we're now starting to see that second wave of early adoption coming into service mesh. We've done a couple talks on Istio in particular here at Cloud Native Madison. We're absolutely interested in talking to anybody who is also playing around in this space, potentially for a future talk here in the next year. The other kind of nascent use case that we're starting to see a little bit of movement on is serverless. And so those, most people are probably aware, AWS Lambda is the most prevalent example of sort of serverless type workloads. But a lot of people are looking at, okay, how can we maybe avoid a little bit of that vendor lock-in by, following these serverless, paradigms on top of Kubernetes or within that CNCF stack. And so again, a very large percentage, I have my notes somewhere here, like 50 or 60% of companies are at least looking at serverless. But it's almost entirely being adopted. 53% of respondents are using Lambda if they're doing serverless. So not super surprising, but this is another space where now that we've kind of got that common underpinning of Kubernetes there, I think we're going to start seeing some more movement in there because ultimately a lot of companies do want to avoid that vendor lock-in. And finally, this is another interesting one for me, which is what are the challenges preventing you from using containers and all the other nice things that kind of come along with that? And the top reason they said was cultural changes, feared by those development teams. So, that's kind of an exercise left up to the readers exactly what that means. Whether it's people who aren't interested in taking on new technologies for whatever reason. The second was security, and I thought that was interesting. For those that don't know, our friends AE Business Solutions put on a conference just last week, Deep 608, around security. And the security space around containers, I think there's a lot of fear, uncertainty, and doubt there. I think actually, if you're doing it right, containers can be as much or more secure to how most companies are running applications today. I think the real change has just been that CI/CD and Kubernetes and all these tools allow you to go so much faster that companies haven't really figured out how to put the right checks in place without slowing down the process of development. And so that's a really interesting space that's evolving as well. We also see complexity and lack of training. I think those are natural things as companies take on new software. It's different from what they're doing before. They need to figure out how to scale up those skill sets within the company. But just wanted to show this back to the community so we kind of have a picture of where the industry is at, what people outside the space are feeling about adopting these tool sets. With that, I want to thank our sponsor this evening, AE Business Solutions. They share our building here. They're down on the 3rd floor, and I want to thank everybody for trudging up 2 flights of stairs to come. Super long walk, yeah. But for those of you that aren't aware, AE Business Solutions has been around for quite a while now, serving Wisconsin and beyond. And I'm not going to read to you the centers of excellence up there, but we have many representatives from AE here tonight, and I'm sure they would love to talk to you if you're interested in talking with them about any of these areas with them. With that, after a quick HDMI switch, I'd like to give a warm welcome to John Moser and Dan Placek, our speakers this evening.
Ooh, clicker time, too. How's everybody doing tonight? It is a lovely Thursday evening.
There's some really comfortable seats right up here. It's a couch.
I mean, we're scary, I guess. So my name is John Moser. I'm the practice lead for AE's network and security practice. This is my compatriot, Dan Placek. Say hi, Dan.
Hello.
Yeah, so we are here to talk to you about end-to-end container security, assuming this thing stays on my ear. So while a lot of the concepts of the talk and presentation that we're going to talk to you guys about can be generalized across the entire AppSec space or app dev space, the principal focus of the conversation that we're going to have today is mostly around application security. So we've got a couple other conversational points near the end about identity and access management, platform security, whether that is securing AWS, the infamous I have an S3 bucket stuck out on the internet and everybody's got access to it, that problem. And then specifically around network security concerns, whether it's microsegmentation or otherwise. There's a lot of areas that are security relevant to containerized applications. But our principal focus for this, if we were to literally talk end-to-end security for containers across all 4 of these spaces, you guys would probably be here tomorrow. And that's even with Dan and I talking as fast as we normally do. So the principal focus of this conversation, just to level set expectations, is that we're going to be talking about application security. And really, the main focus of this is kind of at a 10,000-foot view. If you are a application development manager, if you are a SecOps manager, if you are trying to be someone, if you are someone who is trying to build and manage a application security program, how do you overlay some of the technologies that we're going to talk about across the entire SDLC process? Some of those are obviously new technologies that maybe people aren't as familiar with. Some of those are technologies that we're adopting to a containerized world. So it's kind of the level set expectation for today. And then near the end of this, we'll obviously take some questions that might be a little bit more of a deeper dive, but that's the focus for today. What is interesting is that if you look at security issues, and if you look at the focus of most SecOps programs, even those that are like fully integrated into their development process, it's all very focused around sort of traditional infrastructure security, right? We stick firewalls in front of things, WAFs in front of stuff. We'll talk about that in a little bit. But oddly enough, if you look at some interesting statistics that were gathered from our friends at Veracode about security problems that are noticed or collected statistically versus applications that they've pulled, a significant portion of those, like 63%, fail like basics, like the very basics, like OWASP Top 10, like stuff that we have been talking about for years. Organizations still have a very difficult problem addressing those security concerns. And of course, this wouldn't be a security talk if us security guys wouldn't throw scary statistics up there. But it's something that is very interesting. So as we talk through this, the principal concern for, I think, the talk and the conversation today is how do we start to build into our security program, specifically around container development, container deployment, full CI/CD process. How do we actually start to take care of security problems that in many cases first starts within application development? More fun and interesting, scary statistics, because we all love these. Won't go into this in too much detail, but like interesting stuff, right? Like the very concept of hard-coded passwords existing within applications. Secrets management is still a super difficult problem for a lot of organizations, and yet something that is probably one of the most publicized vulnerabilities or issues that we find. Organizations that check shared secrets into GitHub accidentally. Anybody here accidentally hard code secrets into their applications? If you're not raising your hands, you're all a bunch of liars. Other things like cryptographic issues. There's still organizations out there that believe that even though they are not cryptographers and crypto analysts by trade, that they can develop crypto stacks and crypto libraries for applications. We still see a significant number of problems in applications that are specifically focused around cryptographic security. Even things as simple as, do you have TLS 1.1, 1.2 disabled on your web servers or on your web services? Like basics like that are very difficult. Other things like input validation and issues with unstructured data or unvalidated data input on applications, still very tough, even if you're doing containerized security. So a lot of the traditional problems that we run into in AppSec from the past 20, 30 years still exist within containerized applications. That really doesn't shift. But luckily, there's a few things that we'll talk about that Dan and I will go over that, luckily due to the nature of how applications are developed within a containerized environment, lends very well to solving some of the problems that we've had difficulty solving for the past 20 years. Last couple of things, fun, scary statistics. Of course, if you look at, from a security lens, how long it takes an organization to move from a time of detection to time of remediation, let alone from time of compromise to time of detection. The time of compromise to time of detection is on average about 2 weeks, which is a pretty long time to let an adversary live in your environment, let alone the problem, or even if you've detected it, we're still fixing high critical vulnerabilities, like even a basic SQL injection takes an organization traditionally upwards of like almost a year to actually fix that in production. The last comment I'll have on this is that if you look at open source libraries, really popular way to actually develop applications very quickly. Why reinvent the wheel if 100 other people out there have already done it for you? 300 billion plus open source libraries downloaded last year. 1 in 8 of those contain known vulnerabilities. Not just surprises, not zero-day exploits, not things that all of a sudden we discover are out in the wild and nobody's known about it except for China and Russia and the US, Israel as well. But actually known vulnerabilities, and we're still consuming those in mass. Right? So all real problems that we as both OPSEC and DevSec people have to deal with, which leads us to the typical problem, which is if you look at it from like the DevOps guys, they're like everything's happy rainbows and we make applications and we make money for our business. And then the traditional view of like the sec guys who are like, yeah, but like even your application that takes 3 months to deploy, we have to go clean up the mess, let alone an application that you guys are literally pushing commits out to production and deploys and builds out to production in a hourly fashion. Like how the hell are we supposed to deal with that? So I think part of what we're trying to focus on today is like how do we all interoperate and work with each other better? And part of this is how do we take some of the methodologies that we take from the security side of the fence and push those methodologies into an app dev world? And then how do we also enable our application developers, whether it's containerized or otherwise, it doesn't really matter, but containers are special. How do we let our developers continue to adopt our security programs so that we don't have to keep the sec guys up at night?
So I'm sure everyone's very familiar with the software development lifecycle, SDLC, something like this. And we're going to kind of step through this one at a time and talk about how we can map and bake in security into each step here. Maybe you follow something like this, something like this. We are structuring this around what I've got on the bottom here. And first thing I wanted to do, though, was introduce a concept for anyone who's unfamiliar called shiplap. This is applied to some other things in development beyond security, but specifically for security, what we're talking about here is taking security flaws, vulnerabilities, and finding and fixing them as far left on this process as we can. And there's a lot of advantages to that. A big one is cost. Costs a lot more. Risk is much higher. Obviously, by the time we get all the way to operate here, now we've got a real organizational risk. This is something that can become a compromise, an incident. Really looking at ways that we can move this as far left as possible and bake security into every step in the SDLC.
The ironic part about all this, we'll get to in a few, is that we're actually shift right as we talk about security layers. So that part's kind of amusing. So we threw up some numbers earlier, some statistics that are meant to scare people, but oddly enough are pretty real. The other thing that we wanted to focus on is if you are not paying attention to metrics collection within your program to build application security, whether it's a containerized environment or otherwise, you're doing it your organization an injustice. There's a very famous study from NIST way back in 2002 called The Economic Impacts of Inadequate Infrastructure for Software Testing. Yes, containers didn't exist back then, and the cloud, I think, was probably someone's brainchild, but it's still very applicable to even common SDLC processes and cost metric calculation, where we look at the cost to fix bugs, security or otherwise, defects, take your pick. The further down in the deployment process that we get, the more expensive it gets to actually go and resolve those issues. Right? So the whole point of hopefully what we're talking about today is we give security teams, app dev teams, the ability to fix things earlier on the cycle so that it's not as expensive to the organization to obviously resolve this in the long term. That's a little bit grayed out, but that's okay. The other part that is interesting from a metrics gathering perspective is, again, whether AppSec or the app dev team collects these, whether sec team collects these, whoever collects these metrics, it's important to also look at where defects are being introduced into the application development lifecycle, right? So it's all good to say we are getting better at app security. It's a whole different ballgame if you can show upper management at the end of the day that traditionally maybe we are usually fixing problems very far right. Maybe by the time they actually hit production and then the security team goes and scans it and says we got to fix a whole bunch of problems. But because of the programmatic changes that we've made, we're now starting to notice defects earlier on in the process. We're fixing them much earlier, and we're saving the company a bunch of money, which helps you fund other programs, right? So key part here is metrics collection. Even before we get to all the other cool technology and stuff we're going to talk about, if you are not developing a metrics program around defects collection and being able to, or defects identification and being able to actually relate those to security flaws, it's really tough to solve or to sell these problems to management.
Yeah, and I would add that just anecdotally, as we consult with a lot of large organizations, and something that I've observed is moving a lot of these security processes left in the SDLC makes security a lot less adversarial. We're not getting all the way to production with all these bugs, and it's a fire drill, and you guys screwed up, and now we're vulnerable. You can catch those things earlier, and it improves the relationship between security and development. So we're going to dive into the tech piece now, and I'm going to kick it off by starting a religious war. And so this is kind of all the way on the left, like as far left as you can go. In many cases, language selection is not something you necessarily have a choice with. You've already got developers with certain skill sets. You're already invested in a certain platform. You've already got software written in another language. So this may not be an option for you, but if it is, it's certainly something to consider. I think it'll surprise exactly no one in this room that C is at the top of the list there for a number of vulnerabilities. A number of other ones in there are probably not a surprise either, but I'm a Go nerd myself, so I would certainly advocate for Go, but a lot of the more modern languages, Go, Rust, etc., just quite frankly have security features and inherent security that some of the other languages don't. Some of that is in the form of things like better memory safety and just eliminating entire classes of bugs, and some of it is in the tool set, making it harder to shoot yourself in the foot, giving you feedback during the compile process on things that are insecure. So if you have the choice, it's something to consider. And then another piece of that, container specific, is the security of your application ultimately comes down to more than just the application itself, but also what ends up in the container. So one of the advantages of going with some languages, such as Go or Rust, but there are others that have a very compact footprint for deployment. So in the case of Go, for example, a single statically compiled binary, is we can make container images really, really slim. So on the left, there is an example of building a from scratch container. So a container that contains absolutely nothing other than the Go application binary. That's a huge attack surface reduction, right? We've got no tools available in the environment for an attacker to use, no file system to speak of really. Makes it a lot easier to secure. On the right there, you can see a lot of the commonly used base images, and they vary pretty dramatically in terms of their size, which translates directly to how much stuff is in them. Some of these have hundreds and hundreds of various traditional Unix utilities and other things like that. And those are all things that you have to track vulnerabilities on, keep patched, keep up to date. They're tools that attacker could use if they got in through the application. So the smaller you can get that, the better. And one of the pieces of pushback that I hear on this is, well, we need all that stuff to be able to troubleshoot. We've got a problem with our app, problem with our container. We need tools when we get into that environment. But there are other options to get those tools. You can mount an additional volume, whatever, just for troubleshooting to bring some of those tools into the environment when you have to. I would say whenever you can, reduce the size of your image, and if you can go all the way to 0 from scratch, do that, even better.
So secrets management. We talked a little bit about this earlier. I think Branden alluded a little bit to this in the service mesh discussion. Secrets management is it's an interesting conversation, right? So we all know that we shouldn't hard code passwords. We all know that certificates should be rotated as quickly as possible and should be managed in as automated a way as fashion. I think that a lot of organizations sort of jump the gun on building out their security program for application security by not addressing secrets management long before you're already developing applications. Part of the problem is that traditionally secrets management, whether that is certificate generation by the security team, whether that is password generation or API key generation, take your pick, has traditionally followed a very manual process. One of the areas that we have identified that I think goes a long way to building a more secure environment is by trying to automate the whole concept of secrets management. We'll talk a little bit in a few seconds about ways to do that. But it enables a lot of different things, right? So the big ones are principally that if we are automating the process of secrets management, we can rotate compromised keys and certificates much quicker. The time to live on those can be much shorter, and it allows us to basically deal with security issues in a much quicker fashion. All told, I think this is probably the area that is most talked about in a lot of areas, but is probably the least commonly addressed. And it's an area that, like I said, I think organizations should spend some time building out a good secrets management automation system so that your security team can write policies towards it about who has access to keys, who can generate them, who can push them out to applications. But build it in a fashion that it's a consumable service, just like all the rest of the consumable services that exist within your application security environment. Dan, I don't know if you had any other input on that, but
yeah, I mean, along those lines, I would definitely encourage the use of like what would commonly be called dynamic secrets now. So like there's a lot of the secrets management platforms, I'll use Vault as an example, that have the ability to tie into specific platforms and applications. So Vault, as an example, can tie into a few of the different databases like Postgres, MySQL, what have you, and automatically generate like time-limited leased credentials. So you can hand out to an application a set of credentials that is good for an hour, and then is automatically erased. That is really powerful from a security standpoint.
The key point here, no pun intended, is that while the security team can continue to write policy around, again, how secrets are granted, how they're revoked, who has access to what vaults exist, maybe even the creation of vaults, it is meant to be a collaborative approach to managing, arguably, the keys to the kingdom. If you compromise secrets credentials, if you compromise private keys of certificates or API keys, it is one of the most common ways for aggressors or attackers to get into environments they shouldn't. And so building this programmatically out, again, as a consumable function, still allows security teams to set policy, but allows your developers to actually operate at the speed that they need to deal with this. And then at the end of the day, generate audit data so that we can go in and verify that our secrets management program is working as intended.
This is one of those things, too, that, again, helps with like the animosity that sometimes exists between developers and security. We build this platform out, make it easier for the developers to consume. It's all available over an API. Security guys can still manage all the policy for it. It makes things run smoother.
Yep. Anybody had to wait like a week or two for certificates to be generated? Probably most people should raise their hand. Yep. So some examples, Dan alluded to this. Obviously, there's a bunch of third-party purchasable over-the-shelf tools that you can buy. Most common, hey, there's the lights, must be 7 o'clock. Yeah, so obviously HashiCorp Vault is a pretty popular one. There's also the cloud service providers, whether it's Azure, GCP, and obviously AWS as well, all have their own secrets management platform or program, consumable service. They're all great. HashiCorp, the Vault is probably one of the most popular ones that exist out there, one of the most well-known. But there are some alternatives. So again, going on that whole don't reinvent the wheel if it's not your forte, if it's not something you're an absolute expert in, you don't necessarily have to go and buy an off-the-shelf solution. There's plenty of examples of really good open source secrets management platforms / programs that exist out on Git, as well as other sources. So again, of all the areas that you may want to reinvent, don't do it with crypto and don't do it with secrets management, because there's plenty of solutions that exist out there. And if you get either of those wrong, you're pretty likely to shoot yourself in the foot.
Somebody should tell that to Silicon Valley, because it seems like half those companies have their own secrets management platform up on GitHub. But if you don't have something today, the recommendation that I would give would be Vault, HashiCorp Vault. They do have a commercial product, but it's also open source, and the open source is fantastic. So if you're looking for a place to start there.
Any Vault users in the audience? Not that this is a HashiCorp pitch or not, but just curious what adoption rate looks like. Cool. So maybe I'll just skip this slide because Branden stole my thunder. So service mesh. So obviously service mesh has stuff that it does that is not necessarily security centric in terms of application discovery, service discovery, et cetera. But from a security perspective, there's kind of 2/3 key points that we usually like to talk about. If you're not making use of service mesh within your application platform, It's something that especially the security team should be pushing your app developers to try and integrate. So a couple key areas here, right? So the first is that we can do something that is typically referred to as intent-based security policy. So unlike traditional sort of ACLs or firewall policies where we maybe have a 3-tier application and you've got X number of presentation layer or web servers and Y number of application servers, and I have to write security ACLs that allows 5 IPs that talk to another 5 IP addresses. And every single time that a new container in this particular instance gets spun up or spun down, I get to go manually update ACLs. Specifically around service meshing as a security function, we get the ability to write intent-based policy, which means that, yes, my security team can still say, we're only going to allow web servers to talk to application servers on port 80 or 443, or whatever the port is that you're using, and that's it. And regardless of the number of web servers or application servers or some microservice widget that gets spun up, regardless of the number that gets spun up or torn down, we're going to still enforce that same security policy. So in terms of environments that are highly elastic, highly scalable, both for scale up and scale down, the ability to have your security policies that are enforcing segmentation within the environment adapt to changes in the environment, I think is pretty significant. The second part is usually around crypto. So 2 key components there. The first is that you get native transport encryption for conversations that are going across your different nodes within your service mesh. Important, obviously, if you're traversing across networking that may potentially be compromised or sniffed, but more importantly, it also allows us to do interesting things like mutual authentication. So mutual TLS between the different layers of my service application is important. I don't think anybody would argue that we want to allow certain things fly in plain text across the network. So yeah, a couple of things there. There's obviously a bunch of other stuff that Service Mesh does, but from a specific security function perspective, those are the big ones. Anything else?
Yeah, I would just add that I think standardizing on a service mesh and again providing that like as a service to developers is huge. When they don't have to kind of roll their own security for your various like RPC or API, like internal APIs, just have something built, ready, and easy to use that they can use to connect apps or microservices or containers together in a secure by default way is a huge win. Just touch on this briefly. Don't want to dive into this. Couple memes up here, but I think if you don't have some kind of security training program for your developers, even something simple, I mean, even if it's just a few hours a year, it can go a long way. There's a lot of kind of bug classes that we've been creating over and over and over again for decades at this point that are actually fairly easy to recognize in code. So just have some kind of training program to get some of that knowledge. And an extension of that, and this is something that I really like because this is a way to get like a really tight feedback loop with developers, is there's a number of different solutions out there that allow for what I would call real-time AST, or real-time application security testing. This screenshot in particular is a product called Greenlight from a company called Veracode. There's a whole bunch of others. But the idea is you get real-time feedback in your IDE as you're writing code about security issues. So if you want to advance that one, John, zoom in here. You can see like using MD5 and taking a input string from an end user and then using that to do an exec call, so command injection. You get that feedback right down here in the bottom of your IDE with what the flaw is, how critical it is, line number, even a details button here that you can click to get some additional information on that type of flaw, why it's a flaw, how to fix it. This is fantastic, both in terms of catching security vulnerabilities, but also from the training perspective. Getting that really tight feedback loop, they get that information immediately on code vulnerabilities that they're writing. Going back to the secrets management piece, and we've kind of moved right up here on the top, if you didn't notice that, over to the commit phase. Something that I would advocate doing for every commit would be a secret scan. There's a whole bunch of open source tools available. These are a couple, one from Yelp, one from AWS. They're pretty simple to use. Set them up with Git hooks, and they can search for all sorts of common secret formats. It's a whole bunch of regex and machine learning, probably.
Bingo.
So yeah, get this added. Catch those. I think for anybody who uses Git, obviously once something's in the history, not generally going to get it out. So catch these early.
Anybody familiar with the new announcement from last year with what was it, Microsoft's GitHub Arctic Vault, whatever they're calling it, where they're basically taking every single bit of application data and code that shows up on GitHub and committing it to like some nuclear silo in the middle of, I think it's either Alaska or Siberia or somewhere. So even if we somehow are able to extract that data out and get it out to GitHub, there's a good chance that your secrets are going to end up somewhere in the Arctic.
There was a study done last year, I think concluded in spring. There's a paper out, you can find it, about secrets publicly on GitHub. And they found like, I think 100,000 different secrets that are leaked publicly there. And they were saying that the mean time to compromise of somebody like finding that secret and using it was like 60 seconds. And in 2019, it's insane.
Yes.
So,
if we can scan for our own secrets that are showing up in GitHub, guess what they're using to go out and scan for our own secrets out in GitHub?
Software composition analysis. So this is another thing that you can do during the commit phase, also often abbreviated SCA. A lot of different tools in this space. But the basic premise is looking at all of the third-party code that you're bringing into your application. So open source libraries, et cetera, and analyzing those for vulnerabilities, known vulnerabilities, CVEs, what have you. A couple news articles here. Supply chain attacks against open source projects, huge, big expansion of that in the last couple of years. A big one from last year was a Node.js library called EventStream that got compromised and was pulled in by all sorts of other apps, caused a bunch of problems. On the bottom left here, this isn't actually a security thing, but it's related, and if you haven't read this story, I recommend it. It's hilarious. I like making fun of it.
Unless you're affected by it.
I like making fun of the Node.js developers. Any Node.js developers in here? They love bringing in dependencies that have dependencies that have dependencies that have dependencies. So you get an application that has like 1,000 dependencies. Well, there was a library called LeftPad, and it's like 10 lines of code, like literally, it's tiny. And the developer who wrote it deleted it from NPM. I don't even remember why, some spat, and it broke like hundreds of other libraries and applications. It's a funny story, go read it, but it's just an example of kind of the ripple effect some of this open source software can have, these libraries can have when they're compromised. They're reused all over the place, and oftentimes like you're bringing in one dependency into your application, but if you look at the dependency tree there, it's actually 50 different open source libraries from 37 different authors. That's a lot of risk surface there. So this is a screenshot from a product called Black Duck. It's owned by Synopsys. They're one of the players in this space. Basically just gives you an output of here's the libraries that you have. Do they have any known CVEs? Are these high risk, low risk, et cetera? So something that you can run right as part of your commit process and get that feedback immediately.
So we talked a little bit about this earlier, the human factor. If one set of eyes on code as you're writing it is good, two sets of eyes are probably maybe not 100% better, but at the very least, how many people in the audience within your application development teams do peer review of all code before it actually gets committed? Good. If you're not doing that, it's probably one of the cheapest non-technology driven ways to catch bugs and flaws within your applications. It serves multiple, obviously beneficial, it has multiple benefits, right? First, you get two sets of eyes on code before it hits commit. And second of all, it also doubles as a teaching opportunity. So we talked a little bit about end user training earlier. Use this as an opportunity. If you're already doing it, it's a great opportunity to actually catch flaws before it hits your environment. And it allows things like junior developers to learn from senior developers on how to write code better, not just for better function, but also for security issues and flaws.
Moving right again, so to the build phase here. SAST, static application security testing. So this is essentially taking source code, binaries, and doing some static analysis against them. There's a lot of solutions in this space. There's some open source ones, there's some commercial ones, but they have a giant collection of things to look identify common OWASP top 10 things, look for those sorts of things in code. Top right, this is Vericode's got a solution. That's what theirs looks like. This is actually, I believe, GitLab's, but the idea is right in your build pipeline here, you can get feedback on kind of some of the low-hanging fruit for software vulnerabilities with that static analysis. Often with these tools, you can set policy too. If this flaw is of a certain severity or a certain risk, we want to fail the build, we don't want to proceed, we don't even want to deploy it to test. We need to fix this right away.
Yeah, I can take it. Container image scanning. So the ability, we've sort of not really ragged on open source, but in terms of the ability to go out and scan container images that either exist within your registry, which is typically the integration point and where a lot of the either open source or third-party tools that exist around the borders of this typically go after container images. But the ability to basically look at known flaws that may exist within container images that you are using within your environments. Seems pretty simple, but it's something that I think is, again, frequently missed from a build pipeline perspective. People may be aware of maybe CVEs that exist in container images that they're trying to make use of early on, but are frequently not rechecking this as new CVEs are issued in the environment. It should be part of your continual build process to go in and double check either as part of your build process or as an after the fact sort of hook into your container registry to go in and scan the content of containers within your registry.
One comment on that, we talked about SCA tools. And there's some similarity and overlap here. But the difference there is SCA tools, you're really looking at the application itself and the libraries you're bringing to the application. Whereas this is a bit broader and you're looking at the base container images as well. You would be surprised, especially some of the larger base container images, just how many CVEs there are in those. A lot. So this is looking at all of those tools. Think all the Unix tool set, all those kind of things that you have in the container beyond just your application.
Infrastructure as code analysis. A lot of the topics that we're talking about are very focused on application code. They're very focused on the container images themselves that we either build or make use of. I think an often missed spot within your build pipeline is what are we doing to actually analyze the infrastructure as code images, whether they're Terraform files, AWS CloudFormation files, or other templates, other third-party, basically IAC scripts that you're making use of, analyzing those for best practices to determine whether or not even just your deployment process for actually pushing out infrastructure passes certain sanity checks. We were going to, a couple days ago, we were doing some preparation for this, we were going to give you a nice, lovely link to an application, an open set of APIs that Palo Alto Networks, artist formerly known as Redlock, one of their acquisitions, had freely published out there for people to basically upload YAML files, upload, again, Terraform templates and CloudFormation templates. And unfortunately, they have since pulled public access to that. For God knows whatever reasons, you have to be a customer now of theirs. However, if you go to this little link up here, they have publicized all of their policies and rules that you could technically use to go build your own IAC inspection engine. So go there. There's a lot of other content beyond just Kubernetes YAML policies, and otherwise there's a bunch of stuff for Terraform and CloudFormation.
So I don't know if you can read this from in the back, but like just as an example here, like there's a check in here to check don't run containers as root. They've got a whole bunch of different policies here, like common mistakes that you can make in those deployment files to catch those, as part of your build process and give you that immediate feedback.
Yeah, so go grab a copy when you can before they pull that too.
So I mentioned SAST, Static Application Security Testing. DAST exists as well, so this is Dynamic Application Security Testing. The basic idea here is we're doing testing against a running application. So we've moved right here. We're in a test environment now. The application's running. It's operational. And we have some different options then. So it's more of a black box testing method in that the tool doesn't necessarily have insight into the source code or any of that stuff. You can also catch with it issues that aren't necessarily source code related. So environmental issues, misconfigurations, things like that. DAST, for the most part, is focused really on web apps, which there's a lot of apps now. But SAST is more generalized. You can apply that to pretty much any type of code. Application has to be running, and then the other component is language support. So with DAST, you can test pretty much any web app, regardless of the language it's written in. Whereas for a lot of the SAST tooling, it's limited to a certain number of supported languages because it has to be able to parse that code and look for those vulnerabilities. So that's one advantage it has. It very much simulates an actual attacker. There's a lot of like penetration testing, web app penetration testing tools that are technically DAST tools.
So speaking of pen testing, anybody heard of the concept of continuous pen testing, penetration testing? Yeah, so it's interesting that we look at how fast organizations are pushing out application code or deploying applications to production, but penetration testing or external visibility or external penetration or vulnerability assessments are typically still following a once a month, biannual, yearly testing process, which is crazy in an environment where you have, again, maybe commits that are going out to production once a day, once an hour. So the concept of basically being able to do penetration or external vulnerability testing at the same pace as your applications are being developed and pushed out to prod is something that obviously organizations should be making use of, so that rather than test again once a month, we are literally hooking penetration testing into our build process, so that the moment that piece of code or that application update's been pushed to prod, we trigger a hook into our continuous pen testing environment to actually do the pen testing cycle against that application. Not necessarily in real time, but at least much more often than the sort of yearly tests that we're doing, so that we can catch all the other stuff that may have been missed earlier on in the SDLC with a continuous integration from a pen testing perspective. There's organizations out there. AE works with an organization called Synac. If you guys don't know Casey Camilleri from Sprocket Security, they're a local organization. He's an ex-coworker of mine, so pretty cool guy. So there's obviously some things that you can do out there. You could build your own if you really wanted to and go and script the same process. But there's obviously organizations that are out there that are either doing it from an automated perspective or they're crowdsourcing the process.
WAF and RASP. So this gets a little bit into the NetSec part of this, but I'm guessing most people here are familiar with WAFs. I kind of view this as one of the last lines of defense. This is, if we really screwed up and we've got serious vulnerabilities in our code, we deployed it to production, this is the Band-Aid over the top of that, so it hopefully doesn't get through. A bunch of different players in that space. But a newer technology, and I say newer, it's been out for a couple years now, a few years now, is RASP, or Runtime Application Self-Protection. And this is a technology that basically takes the capability of a WAF and embeds it directly in the app. So this is usually best with applications that have some kind of runtime, so talking like C#, Java, languages like that. And the basic idea is during the build process, you include a library, essentially, the RASP library, and it can hook into a lot of the lower level functions of that platform. So hook web requests, database calls, things like that, and apply those same kind of security controls from within the app itself. And one of the big advantages of this is the ability to get very good feedback from it when you do have vulnerabilities. So in the case of a WAF, you get an attack, and you might end up with a URL or something, maybe some headers. It'll give you just a little bit of information on what the actual vulnerability is. Whereas with RASP, since it's integrated into the app itself, you're going to get line numbers, stack traces, whatever, the complete set of data on what this vulnerability is and where it is in the code base.
Container runtime security. So much like
right again here into
we're moving way right to operate, right? So again, sort of the last bastion of hope for dealing with some of the security issues we've talked about. So similar to how RASP operates, container runtime security is meant to look at a container's actual runtime state, whether it's production container environment or QA or dev. The key point here is that we are able to basically hook into the container environment, observe how a container is behaving, see whether or not there is, or perform some sort of baselining, right? So if anybody saw Branden's talk at Deep 608 about Falco, was a great insight into some of the things you can do with that. But the concept here is that a container, even in a very dynamic environment, should generally behave the same way day in and day out. If we can observe its behaviors, we can sort of see what processes are being launched, what are typical network sockets that are being opened between the different services, whether or not a bash shell being spawned in the container is something that normally happens. We can baseline that and then write policy to enforce container behavior as it is running in production. Bunch of different companies that exist out there for it, a couple that are up there. Obviously, Branden talked about Falco, Twistlock, Placek. There's a bunch of others that out there that specifically specialize in container runtime security.
And I'm not going to go deep into this. This is a topic of its own. I think a topic that's probably been covered a little bit before as well. But there's the container security, but then you're usually running this on some sort of broader platform. In most cases, that's going to be Kubernetes. Obviously, we have some more serverless, I guess, container deployment options now on the public cloud providers. But Kubernetes security is an animal of its own. A lot to cover there. One thing that I would really recommend, there was a paper, this came out, I think, relatively recently, authored by someone from Microsoft and someone from Placek. There's a bit.ly link at the bottom there if you want to give it a look. It's really nice in that it is short. They took like all the common Kubernetes security stuff you'd want to know and packed it into like 5 pages. Very approachable. So if you haven't seen that, check it out. It's worth a look.
So the laundry list of stuff that we didn't cover. So this was mostly focused on, like I said, application security at the start. There's a variety of other areas. Dan mentioned, obviously, a Kubernetes deep dive. This didn't touch a little bit on NetSec microsegmentation, mostly realized through like a service mesh. There's obviously other ways to deal with that as well. Cloud platform security I alluded to at the start of this. A couple other things in here that I think are super important that aren't directly container security, but if we're looking at sort of our shift left methodology of solving problems much earlier on, identity and access management strategy, specifically as it relates to things like layer 8 security problems. And there's two things I'll denote here before I think we wrap up. If you don't have a good strategy around managing things like credentials, and when I say credentials, I don't mean like shared secrets, I don't mean certificates, I mean developer identities, or people who have access to Amazon service accounts, or any other number of things that lets someone log in, say, to your registry and push out new container images or modify policies. If you don't have a good identity and access management strategy to be able to quickly regulate who has access to what, revoke access to it as needed, and provide structured policy, I think one of the issues that we're going to see pop up more and more are layer 8 centric attacks, and specifically around things like credential theft. If you don't have a good way to detect when, say, for instance, one of your developers who is working really late at night at 3 a.m. or whatever late at night is to them, and accidentally gets hit with a phishing email, and now someone else has their credentials, and they can now have access to keys to the kingdom. If you don't have base levels of detection to be able to detect that sort of thing, all of the stuff that we've talked about is pretty much fall by the wayside if somebody can get access to that credential set. Things like multi-factor authentication for logins are super critical to people that are developing applications. They're just as critical as obviously credentials that belong to the CFO of an organization. There's some other things that I think we typically talk about with respect to like bug bounty and reporting programs. One of the other, I think, major challenges that we generally face if we're developing applications is how easy is it for a third party to report that they've found a critical flaw or any flaw within an application that is, say, publicly exposed? Is it easy for me as a bug bounty or researcher to actually report that issue to you, or do they have to go hit Twitter and ask, how do I report that there is an application flaw for this particular software platform? So if you don't have a good structured either bug bounty or reporting program integrated into your whole process, I think that's also equally as critical as a miss.
For anyone who's not active on InfoSec Twitter, which is its own little weird community, it's stunning to me how often security researchers like find a major vulnerability or leaked data or something, and literally can't get a hold of anyone. Nobody responds. They open some ticket, no answer. So make sure they can get a hold of you if there's a security problem.
Oops, wrong direction. And that's it for the presentation. How do we do on time? Perfect. Excellent.